So section 2.3, the functions. So this is where we're going to have functions, and we're going to, I would say, just the probably easiest way, insert one function or insert it into the other function, and then doing some context of what we're looking for. So we have this little dot right here that you see, this little circle. This is not a multiplication sign. So I know students, when they see this, they think multiplication, you're supposed to multiply the function times the function. That's not what it means. So when you see an open circle like this, that means composite. And this is what we're going to do as far as steps for composite. And the first function that is represented in the composite form is going to be considered to be our main equation. So main equation means that's what you need to go ahead and write down on your paper, is that main equation. Just go ahead and write it down because that's the one we're going to be focusing on. The second equation, for whatever this letter is, it can be G or H, whatever the case would be. This means that we're substituting inside the main equation. So this equation here, anytime we see an X, this is kind of like what we did for the difference of quotients, where we took away the X and put in X plus H. Well, this time we're going to take away the X in the main equation, and we're going to insert this whole equation of G, whatever they give us for G, into it, and then we're going to solve, simplify, solve. If it tells us to put in the number, we'll put in the number to get the answer. So here's an example. First function of f of x is 3x plus 2, and then G is going to be x plus 5. So what we're going to do is FOG, or F composite G, which means, again, this is going to be considered our main equation. And we see one x, so that means we're going to get rid of this x, and we're going to insert G, which is x plus, into where this x is, and put it in parentheses. So you can see from here, we took away this x, and we put in x plus 5, and just left the 3 and left the 2 on the end. So this what all the composite means. It's just, again, we're taking the second equation because the G came second, put it inside the main equation, and then we're going to solve from there. We're going to distribute the 3 inside to get 3x 15 plus 2, and then combine like terms with the 15 and 2 and get 17. So that's going to be the answer for F of G, F composite G. So if we switch it and say G composite F, this time the G is going to be our main equation, and we're going to insert all of this into where we see the x at. So since there's only one x, we're going to take 3x plus 2, put it where the x is, and then put plus 5 at the end of it. Again, you always want to kind of put it in parentheses when you insert it in, because it helps for negative signs that we have to need to distribute in, and all that kind of stuff that we need to be concerned about. So once we do that, we see that we have 3x plus 2 in parentheses plus 5. We add the 2 and the 5 and get 7. These are the two steps I kind of broke down to have students understand what we need to do to find the domain. So it says first we need the domain of both functions as a composite. So once we get our answer, so once we find these is considered to be the composite. So the composite of G of F is 3x plus 7, and then the composite of F of G is 3x plus 17. So that's the first part we're going to be finding for what I mean by both functions. Once you do the composite and put them together, we need to find the domain of that answer. That's the first thing we need to do, and have it, kind of set it off to the side as far as the domain is. Then we need to find the domain of the second function. So whatever comes second in the composite is the one we need to find the domain for. So for instance, this means when we get the answer for both f of g or f of g, that's going to be the first domain. And then we find the domain of the second part, which is the g and the f. And then we're going to find out what they common, and that's going to be the domain. So once you draw your number line, whatever overlaps, like we talked about last, I think, Monday. Whatever overlaps is going to be the domain for the composite. So that's how you need to find the composite. Find the domain for the first part first, and then the second one next. And then put them together and define the domain. So looking at this one here, we're going to find the composite first. Before we find the domain, remember we have to do both first. So we got to figure out what the composite of f of g is. So kind of go ahead and set it up so we can kind of get, so you can kind of get a feel of what it should look like set up by doing just a composite first. F of g. So I do understand there's a fraction involved. Or hopefully you at least got to this part where you just substituted this x for 1 over x. That's the first part of f of g. I took the second equation and inserted into the main equation for any time I see x. Now, to simplify, we want to get rid of this. We want to get rid of the fraction by multiplying by x over x, because anytime you multiply the bottom part by x, the x's will cancel out. So we have to kind of distribute. Take multiply to this one, the x's cancel out, and then take this x and multiply by this 1, and we get 7. So with this x being multiplied by 1 over x, it cancels out, leaving you with just 7. That's why we have it here. And then take this x and multiply by this 1, and we get the x in front. And just multiply together 3 times the x gives us 3x. So now we need to find the domain. Since we found the composite, we need to find the domain of the f of g composite. All the numbers except for 7, because why? If I plug 7 into the bottom, 7 gives us 0 on the line, which gives us that red flag. That's the only in the number line that's not for this problem here. It's an answer. If is the only number. Any other, again, you're going to get some kind of, be a weird answer, a fraction, a decimal, whatever case. 7 is the only one that's defined. So our number line is going to be from negative infinity, or the domain is going to be negative infinity to 7. The infinity gets a parentheses. The negative infinity gets the parentheses, comma 7, and then the 7 also gets the parentheses. So we found the domain for both together, and now we found the domain for the second one. Now we kind of got to overlap them in that number line that I was talking about to see how do they overlap to find the true domain. So from negative infinity to 0, union from 0 to 7, union from 7 to, this is going to be the domain for f of g, the composite for f of g. So to kind of recap of what we discussed, we know this domain here is from negative infinity to 7 and from 7 to positive infinity. However, the domain for this one is going to be negative infinity to 0, and then from 0 to positive infinity. So let me see if I can try to put this on my whiteboard so you can kind of see how the layout. So negative works for this one. And then also remember, all we have to go to 7. The domain for this one here is going to be negative infinity to 7, still included into this domain here, which is also included to here we can use. However, to stop it when we go to 0, 7, because I can't go past 7, because remember, I'm using for this one. So we come 0, it's going to be the next domain for this one. And then remember, 0 don't work up here. Then we go for infinity, which is also included in this one. So while all 3 of these will be the domain for the composite of f of g. Now for the second one, we're going to do g of f. So for this one here, we're going to take the main equation, well, this time is going to be 1 over x, and we're going to take this x and we're going to replace it with the second equation, which is going to be 3 over 1 minus 7x. So this used to be 1 over x, but now we took the whole function and replaced it for the second part. So if we do the whole keep change flip, so this one here we change this to multiplication and flip this guy, do the reciprocal. 1 times 1 over 7x over 3 gives us the same answer for the g of x as far as the composite. So going back to the domain, we need to figure out the domain for this one. And the domain for this one, because there's no x bottom, this is considered to be all real numbers. Now I know I said if you see a fraction, that you have to set the bottom equal to 0, but there's nothing to set equal to 0 to the bottom because there's no x. So for this particular one here, it's going to be all real numbers because every number is going to work for this particular problem. Now we find the domain for the second one, which we already discussed. For this one here, if we set the bottom equal to 0 for this one, then and set it equal to 0, we're going to get x is going to be equal to negative 1 over 7. So the domain for the second one combined with the one over here for both is going to be negative infinity to 1 over 7 union 1 over 7 to positive infinity. Even though we have all real numbers for this one, the only one that's going to work for both together is we have to use the domain for this one, which is going to be negative infinity to 1 over 7 union 1 over 7 to positive infinity. Because this one here works for this one also, we're going to make this one going to be our domain for the composite of g of f. And like I said before, I'm going to make a separate video of showing the layout of the number line off the Google Meet so we won't have the kind of lagging issue. All right, so for these particular ones here, we're not finding the domain, but I would like for everybody to practice figuring out the composite for each and then simplifying it. If you have a number on the outside here, that means now once you do the composite, I want you to take that number and put it in for every x that you see. So if you have 1x, you put 7. If you have 2 of them, you put 7 for both of them. So, and then figure out what the answer is when you simplify. So take a few minutes to do that, and I'll call on some people to type in the chat box what the answer should be. So for part A, we're asked to be the f is going to be our main function. So this is 2x minus 5 is what we need to write down for our main function. And then we're going to take g, which is all of these 3 parts, square minus 3x plus 8, and plug it in for this x here. So remember, this used to be 2x minus 5, just like we had up here. That's our main equation. But I took away this x and put in this whole equation of g because it came into the problem. So this is supposed to be 2x minus 5, but put g. So now we're going to just distribute now. This 2 times this 2x squared gives us 2x squared. This 2 times the 3, negative 3 gives us minus 6x. And then the 2 times the 8 gives us 16. Then minus 5. Then we can drop. As soon as you distribute, you can drop the parentheses. Now we're going to collect like terms. And we say that the only thing that's like is the 16 and the minus 5, which is positive 11. So the final answer should be 2x squared minus 6x plus 11. So good job, Mary, on getting the answer correct in the chat box. Does anybody have a question about this one? So this one, the second one, is going to probably be just a tad bit more work because we take the g, which is going to be our main equation. I'm sorry, g is our main equation over here. And then we have to take this in and put it in 2 times now because we got to win for this one and this one. So this one might be just a little bit more as far as the length. Where's the answer to this one? Oops, I must have deleted it. I will work out the g and show you what the answer is for this one. I think I might have deleted it out of my screen. So we'll come back to this one. B. So for this particular one here, you can do it one or two ways. So this was going to be the answer for, they plugged in the 7 and went ahead and did the 7, and then at the end they got the 67. I think somebody already got that correct. Yeah, Jules, you got that right on that part. So what they did for this one is they went ahead and before they even combined the problems, they went ahead and plugged in the 7 for F and then plugged in the 7 for the G one. So they plugged in the 7 for each one, got the answer to be 36, and then plugged the 36 into for the G part. So which makes it a lot easier. So what am I trying to say for this one? Instead of us plugging in all this equation in for X, it's better if we just plug in just the number instead of the whole equation. This way it makes the problem a lot easier for this one. So when we plugged in 7 for this big equation, we got 36. So 36 is the only one I'm plugging in for the X, not the whole equation. So it's a lot better when you have a number because you can actually plug in just the number for X. So 2 times 36 gives you 72, minus 5 gives you 67. G of F for this one here, again, we're gonna plug in the 7 for G and just get what the number should be. So 2 times 7 is 14 minus 5 gives us 9. So 9 is going to be a lot easier to plug into this whole equation instead of the whole function 2x minus 5 for this particular one. So we plugged in 9, we plugged in 9 here. We got our answer. We got 62 to be the second part of B. So G of G for this one here will be 1. This time for this one here, we're just plugging in 1 for the G and getting our answer. Once we plug in 1 for that first equation, we know the answer is going to be 6. So again, we take that 6 and plug it back into itself because we're using the second one. 6 squared minus 3 times 6 plus 8. And then we put this together and we put this in the calculator and then we get 26 for part C. And the last one for this one, F of G, I think Lindsay had put in here. Hopefully this helps you out, Lindsay, for this one. So this one here, we had an X. We're not plugging in any numbers, so we're just going to keep it as X. Notice for this one, remember the Fx was 2x minus 5. And when I plug in the same equation, which is going to be 2x minus 5 into x, this is what I should get. Then I distribute 2 times 2, 4x, 2 times this gives you 10. Then I take the negative 10 and the 5 and gets 15. So it should be 4x minus 15. So Lindsay, does that help you out a little bit? The last material concept in here is going to be decomposing in a function as a composition. So what's going to happen for this one is we're kind of going to work backwards. This time I'm going to give you the answer of F of G. So I'm giving you the answer to be, 4x minus 15 and so forth. We're going to actually give you the answer before we actually work it out. And we're going to separate it now. You have to tell me what the G was originally and what the F was originally. So what is the F and what is the G originally before we even get started? Because this is the answer once we actually do the composite. But what would it actually be? The F will be and the G will be. So what we're looking for is what can we substitute in? What looks like it has been substituted in? What looks like we actually took away an X and substituted something in? Whatever that substitution part we think it is going to be our G because it came second. And that X that we took away, once we replace it back, that's going to be our main equation. So in this case here, the f of x is going to be x. The original f function is going to be x over x raised to the 5th power. And then for g of x is going to be that 2x minus 3. So this one here looks like it's got substituted in. So if we take that out, put the x back, we know that this first one's going to be f of x, and this one's going to be g of x. And this is going to be the answer for any time it asks for decompositing a function. So that would conclude section 2.3.